Hello, and welcome to another YouTube video. Today I'll be attempting to demystify a little bit of computer magic, specifically Control+C. A lot of new programmers are taught that Control+C is kind of just a magical way to close a running program, but few actually seem to understand how, kind of what's happening under the hood. There are two things going on here, two main things. One, your terminal is treating this character specially, and two, somehow that's getting sent to the process itself, and the process is handling it in a way. So let's give a basic demo. Basically, let's say we want just a simple infinite loop that prints out 1 and sleeps for 0.1 seconds. This will basically just loop forever because true will always evaluate to true, and then you'll have a 1 printed every 0.1 second because this will sleep for 0.1 second in between them. So you can run that just by doing so, and it will do exactly that. And you can type normal characters, you can hit enter, nothing will happen. But when you hit Control+C, you will get that output, which is quite a bit different. And you can see here that a keyboard interrupt exception has been raised. And this is actually the same keyboard interrupt that you can raise manually by doing something like this. But you'll notice one key difference is that we're literally raising a keyboard interrupt here, but here a keyboard interrupt is being raised during the sleep. So something funky is happening here with this Control+C. So the first thing we're going to take a look at is the Term.ios manual page for Linux. Term.ios is basically a wrapper around the syscall interface, which is an API provided by the Linux kernel. It's just a thin C wrapper that basically provides us a few functions to interact with the kernel and some constants and such. But we're only really focused on two things here. TC getAttr, I believe this is terminal control get attributes, and TC setAttr. Basically, get the current state of the terminal and set the current state of the terminal. So basically, we're interested in finding a way where you can change the terminal in a way that will make it not do this when you hit Control+C. And to do that, we basically need to get the current state of the terminal, modify it, and then set it back. And then after we set it, it shouldn't do that anymore. So let's try that. So Python provides a wrapper around this C wrapper. So we have the Linux syscalls, then we have the C wrapper on top of that, and then we have the Python wrapper on top of that. But they all basically have the same interface. So to get the current state of our terminal, we can use term.ios.tcgetAttr, and then we need to provide the stream that we want to fetch. In this case, we're modifying the input stream. So we'll want to get the standard in file descriptor number. To do that properly, we can do something like sys.standardin.fileno. That'll give us the file number, and then we can just pass this in here. And then let's just print out the current state so you can kind of see what's happening here. And then we'll just, raise an exception so it stops. So let's run that program. And you'll see we get this exception at the end, but this is what got printed out. And it basically just looks like a bunch of hot garbage that you can't really understand. And it's a bunch of data, and we need to know how to interpret that data. So basically, we can see here, there's the structure of this Term.ios, the Term.ios structure. Usually you get a pointer to this, but in Python you just get the object itself as a list and a list of nested lists. But basically this is what's happening here. We have a bunch of input mode flags. These are all just flags. A bunch of input modes, output modes, control modes, local modes, special characters. We're only interested in local modes. So let's look at the L flag stuff. Here are the constants. You have this isig, icanon, basically all these different flags that you can set to change some local flags in the terminal. But we're specifically interested in isig. When any characters intr, quit, susp, or dsusp are received, generate the corresponding signal. So basically what's happening here is the Control+C that you're using is the intr character. A signal is basically an event sent from the operating system or the kernel to a running process to perform a specific action. There are default behaviors defined for many signals, and you can see a list of signals by doing something like kill -L. These are the default signals. These are basically user-defined signals where you can define your own, and I'll actually provide a link to a simple example I wrote of how to use these, and I might do a video on it in the future. But these are the ones we're interested in, and specifically we're actually interested in sigint. You'll notice this is basically called siginterrupt, and you'll notice that's quite similar to keyboard interrupt. Python just puts keyboard in it because it's generally done through a Control+C. Now, one thing I want to make clear is that when you hit Control+C, the only thing that's happening is intr is received, and it generates a corresponding signal. So we can actually look up here what basically signal is generated. So I pulled up a little page, characters that cause signal. This is in GNU specifically, but the only difference is DSUSP, and we won't even be looking at that. But basically, you can see here, this is the subscript for the inter character in the special control array, yada yada yada. The interrupt character raises a sigint signal for all foreground processes, yada yada yada. Okay, so, oh, and then you can also see, typically the inter character is Control+C. And you can also see this is Control/ or Control \, Control+Z, Control+Y. We'll get into that in another video, perhaps. But anyway, we're going to focus on sigint. So one thing I want to make clear is that there's no magic happening here. If you just run this loop forever, oops, I actually just did Control+Z. that's what it does. If you just run this loop and you open up another terminal, you can actually get the process ID of this process. You can do that using like ps-a, see Python 3.9, this is your process ID. If you send the signal, if you remember sigint is 2, if you send signal 2 to this process ID, you'll get the same thing. It's not just Control+C that does this. Control+C just sends this signal to this process, and no matter how you do that, you're going to get the same keyboard interrupt. So all this process is doing is handling this signal interrupt, and basically when it gets it, it raises this keyboard interrupt wherever it is. So we happen to be on the sleep here too. So how can we now change the behavior of this keyboard interrupt? And we can do that using the signal. Actually, maybe, let's go through the stuff up here first. So we have this current state. So actually, how can we modify this state so that it doesn't handle the signal, or at least in the way that we're expecting it to? So if we go back to this, basically, when this signal is enabled, it will handle these characters and send a corresponding signal. So how can we modify this current state in a way and save it back using tcsettattr to basically just make this not a thing? There's a nice little module called tty in Python, and that basically just gives us some nice flags so we can index it. So we get like tty.l flag, and that's just the proper index in this data for us to find the right attributes. You can just use like an int, but it just makes it a lot prettier. Anyway, so basically what we want to do is we want to do current state, and then we want to index it with the L flag. That'll get us to the local flags parameters, the local flags. And then inside of that, we want to edit the isig flag, and we want to disable it. We can disable it by basically flipping the bit. Oh, actually, sorry, wait, I'm doing this wrong. Term.ios.isig. So basically what's happening here is we're editing the local flags of the current state, and we're disabling isig. If you don't know how this works, I might do a video on bitwise operations in the future if people find that interesting. But I don't want to go down a rabbit hole right now because there's a couple of others, and it's just not really the point of the video. Basically, just know that this is, if this flag is enabled in the current state, it will disable it. So the next thing we want to do is we want to save it to our file descriptor. So we can use that. We can do that using termios.tcsettattr. Now, this is a bit different than getattr. If you look at tcsettattr, you'll see tcgetattr, it just takes a file descriptor, and actually, well, Python's a little different. It just takes the file descriptor. But basically, actually, I'll open up the Python one just for clarity. Yeah, here. So this is a wrapper around this, which is a wrapper around the syscalls. basically, tcgetAttr, you just give it a file descriptor, and it returns the list containing the tty attributes for the file descriptor. It actually tells you the ordering of them. So L flag is actually only equal to 0, 1, 2, 3. So this is just the index of it. So this is actually just 3. But this is just a nice way of writing it. Right, so it gives you back this, and then you can use tcsetAttr, but you'll see this takes the file descriptor, when, and attributes. Attributes is just what you get back from tcsetAttr and what we've modified, the current state, but when is a bit interesting. This is basically when it will edit the state. So you can make it so it edits it immediately, which is what we'll do, or you can also pass in a few other parameters that's basically like when the next time the buffer is flushed and stuff like that. But we just want to set it immediately. So what we're going to do is we're going to pass in the file descriptor that we want to edit. We're going to pass in term ios dot, I believe this is tcsa now, which is just edit it now. And then we're going to pass the current state in, which is actually desynced. It's no longer the current state because we edited it. But this is basically just going to set our new terminal settings. So we're going to just print set, and then we're going to run the same loop. And what we expect now is that this should be disabled. So the signal should no longer be sent through to the process. That's kind of the idea here. So now, if I run Python 3.9 main, you'll see it's set. And now when I Control+C, nothing happens. How magic is that? Now, this actually kind of raises an issue that it's like, how do you close this now? And there's a little magic trick. Basically, Control+C generates sigint, which is known as kind of the most graceful way to tell a process to shut down. But there are more kind of, aggressive ways to do it. The next step up is known as sigterm. This is sigterminate. And if you remember, we can send signals like this. This S parameter is just the signal number. You give it the signal number and the process ID. So let's go find our process ID. And then we can do kill minus S, 15 for sigterm, and then our new process ID. And that will terminate it. Now, just for learning's sake, there's also one step up from this, which is sigkill. Sigterm, I'm not actually sure the differences between sigint and sigterm. Maybe we can do a video on that one day, or you can look it up now. But basically, it's just it's a little bit more of an aggressive way to shut it down. But sigkill is like the king daddy of like killing. So basically, I don't even think it asks. It doesn't even inform the process. I think the kernel just kills it. Is the idea. So it's basically like if your process is hanging for some reason and sigterm can't even kill it, this will just wipe it off the face of the earth. So you do 9 and then you get your process ID and kill that, and that'll just kill it no matter what's happening. The process can't handle this at all. You can handle sigterm. So like that's the thing, is you can make it so sigterm gets ignored, but you can't ignore this. Let me get some water. Right. So the next thing I want to do is not just, one important thing actually is even if we remove this like setting code and we run this, we still, wait, what? Did I restart the terminal? Interesting. I thought that would actually, somewhere our terminal settings got reset, because basically what I was assuming is we've modified the terminal so it'll actually keep the, like we still won't be able to Control+C, but I guess at some point it got reset. Interesting. But basically the point there is, once you set terminal settings, even if you like exit out of your program, usually the terminal settings will stay set because you've actually set it to the terminal itself. You're not setting it to the process. That's one critical thing to notice, is you're setting it to the terminal. So you would have to restart the terminal. I'm actually not sure where the settings would have gotten reset there. Maybe I missed something that I did, or one of the signals did it. But I'll actually look into that, and maybe I'll post it in the comments if I figure it out. But anyway, the next thing I want to do is show you how to handle signals. So like have the terminal still send and generate the signal to the process, but change the handling on the process to not just raise keyboard interrupt. So we can do that using this signal module. We no longer need any of this stuff. Huh? So let's actually open the signal module on Python. So actually, let's open it on Linux too. So basically, this is the same sort of thing. It's just a wrapper around the syscall interface. in C, and then the Python is a wrapper around that, but they provide basically the same interface. So yeah, basically there's this signal function. It takes a, where's the nice part of it? Yeah, signal sets the disposition of the signal signum to handler, which is either sigignore, sigdefault, or whatever. Basically, you can give this a signal that you want to change the behavior of. So like signal.signal, that's this in Python, because we're importing the signal module, and then it's the signal function in that. Kind of like this is the signal library, this is the signal function inside of it. And then we want to give it the number of the signal. So you might remember sigint is 2. The signal library also gives a nice enum for this. So instead of 2, you can write sigint. But this is just 2. And 15 is term, and 9 is kill. Well, you can't handle kill. But basically, we need to give it a handler now. So this thing takes a signal number, and then the handler that you want to attach it to. You can also give it sigIGN if you want to just ignore the signal entirely, and then sigDFL if you want to set it back to the default handler. But we're going to write a custom handler. And basically, this thing takes a signum. Handle is called with an argument signum, and then Python attaches another argument to it. I wonder if I can find it. Don't know. But basically it attaches the frame. So you get a signal number, which is an int, and then you get the current frame of execution, which is like, if you have a stack trace and you're like 3 function calls deep, it will return you the current frame of where your code is, like what level of the function call stack it's at. And that actually defaults to none, I think. It's an optional frame, but it can be passed in. And it will be passed as none if it's not existent. But we're just going to print like received signum. We're just going to print out that we received this signal. And yeah, that's it. And then we're just going to pass the handler in here. So basically, we're registering this signal to go to this handler. So instead of like Control+C raising keyboard interrupt, it's just going to print received signum. So let's run that. And then let's Control+C. And you see we're receiving 2. Pretty cool, right? Now, it's only registered right now to receive sigint, so if I send like sigterm, it's still going to go to the default handler. What? Oh, wow. But you can also handle sigterm, so let's say we also wanted to do that. Signal.signal, signal.sigterm, and go to handler. Run that, send 15 to this bad boy. And you'll get received 15 and receive 2. So now the only way to kill it is 9, which is kill. And let's actually try handling that. Signal.sigkill. So remember I said this one is unhandleable. Let's see if I'm a liar. What? Oh, you can't even pass it. Yeah, so it doesn't even let you like pass it. The kernel literally raises an error when you try. So even cooler. Or actually, I don't know if it's the kernel denying it or Python not having it handled, but nevertheless, I know you can't handle it, and that's why Python wouldn't have it defined if that's the error. But yeah, that's basically what I wanted to kind of show in this video. When you do Control+C, it is handled by a special flag in the term iOS module that makes it send a signal when the characters enter is the one we're using, generate the corresponding signal. That corresponds to sigint here. And sigint, when you send it to a process, the default handler raises a keyboard interrupt exception. And yeah, I guess keep on reading from here if you're more interested. But yeah, thank you for watching and hope you enjoyed. If you have any other requests for this sort of stuff, this is kind of what I'm interested in, so just leave it in the comments and I'll get to it. Thanks.